In this video, of Algebra 1, we're coming from Chapter 1, Lesson 4. We're going to talk about the distributive property. Now, it's something I've alluded to in the past with some of my 7th graders, it's something we've mentioned. But now we're going to actually go a little bit more in depth, make sure we understand how to do it with any situation. Anyways, let's do this. Our objective is, as the student, I can use the distributive property to evaluate and simplify expressions because I will multiply what's on the outside of the grouping symbols, or parentheses, by everything on the inside. So an example, if we were to use letters, I would do A times B, and I would do A times C. So A times B, there's a plus sign there, so I'm going to say plus. Not necessarily because there's a plus sign, but because everything's positive. A times C. And so that would give us AB plus AC. That essentially would be using the distributive property to simplify that algebraic expression. Most of the time there will only be one letter and the rest will be numbers, but I was just giving you an example with symbols so you see what it's doing. Now let's do some examples. So before I jump into doing some distributive property, I want to show you how we can almost prove it using things that we would do otherwise and show you it kind of equals the same thing. So what we have here are just two multiplication expressions. There's no distributive property it looks like as of now, but I want you to see we can purposely, you wouldn't normally need to do this, but you might do this mentally when doing mental math sometimes. We can make these into distributive property, set them up so that we can use distributive property. Let me show what I mean by that. So for the first one, we could say 4 times, but instead of 4 times 15, let's think of another way we can get 15. One possible way would be 10 plus 5. And I think you guys would agree if we were to do the order of operations, we would still end up with 4 times 15 and still end up with the same answer. Now, let's do the same thing for the second one. We're going to set them both up at the same time. Instead of 6 times 26, we can do this in two ways I could think of. We can do this as 20 plus 6 in here. Or we could have done it as 30 minus 4, because both of us will give us 26. We would still end up with 6 times 26. But I'm going to make a point doing it both ways with those. And for the sake of argument, we'll do that for the first one as well. Another way to get 15 would be 20 minus 5. And in fact, you will have questions where they'll give you something like 4 times 15 or 6 times 26, and they'll ask you, and they'll tell you to rewrite it so that you can use the distributive property. So that's kind of what we did here with how we rewrote each of these. Anyways, let's get to it. What I mean by the distributive properties, remember that example I showed you on the last page. If you take what's on the outside and multiply it by everything on the inside, so that means we're going to have 4 times 10, and then positive 4 times positive 5, is positive 20, because I said positive 20, there's a plus sign there. Oh, I already jumped to the answer, positive 20. Anyways, so we're going to have 20 for that, for the second half. In the first half, we're going to have 4 times 10 is 40. So we have 40 plus 20. Well, 40 plus 20 is 60. And that checks out what we kind of already knew, that 4 times 15 equals 60. But I want to show you it equals the same thing. And maybe some of you might consider using this for your mental math. Now let's go to the next one right below it. We'll do this one in blue. 4 times 20 and 4 times negative 5. So 4 times 20, and then 4 times negative 5, think of it this way. A positive times a negative is a negative, so we're going to put a minus sign there. We're going to say 4 times 5. Now, technically you could have gotten away with maybe doing it slightly different. Some of you may have preferred to have done it as plus 4 times negative 5. But even if you did it that way, you're still going to end up with the same value. You're still going to end up with a negative 20 there or a minus 20 there. You're essentially still going to have to do that. So however you write that is up to you. My personal preference, and I think a lot of you may end up doing the same thing, is maybe just imagining positive 4 times negative 5 is negative 4, having it the first way we had it. Alright, so now we would say 4 times 20 is 80. 4 times 5 is 20, so that means we have minus 20, so we have 80 minus 20. 80 minus 20 is 60. And again, that's the same answer we got above using the distributive property. Now let's do it again for the ones on the right. If you haven't done them, maybe try them on your own first. So 6 times 20, 6 times 6, and the 6 times 6 are both positive, so I'm going to put a plus sign there. 6 times 20 is 120, 6 times 6 is 36. We're adding those together, 120 plus 36, so that's 156. So that means 6 times 26 is 156. And again, like I said, some of you may start developing maybe a mental math trick of doing this sometimes. This might be how you do it in your head. Some of you might already be doing it that way, and that's perfectly fine. All right, let's do the last one. The last version, 6 times 30. And I'm going to do it the way I did it over there. Positive 6 times negative 4 is negative. So I'm going to say negative 6 times 4. Now, then we can go forward, and 6 times 30 is 180. Negative 6 times 4 is negative 24, or minus 24 in this case. 180 minus 24, that's 156. So we still end up with the same answer. So I wanted to what I essentially want to show you is if you knew what was inside of the parentheses, yeah, you could do it the old-fashioned way. You could do 10. You could have done over here 10 plus 5 first to get 15 and then done 4 times 15. Yes, of course. But the point is I want to show you guys that we're allowed to do this, and we're especially going to want to do this when we're trying to simplify expressions or equations where one of those things inside of the parentheses might be unknown. It might be a variable like an x or a w or y or whatever. It could be a letter, so we wouldn't have a choice but to use the distributive property. It's going to be the only way to simplify those. And those are some examples we're going to do now. I just want to show you guys how and why it works. And so I want to give you an example where we knew both those numbers on the inside. So on this screen you'll see 4 different examples where we're going to use the distributive property to simplify them. And I wanted to kind of make a point with you that it doesn't, look at all of these, they're all going to be the same exact skill. We're going to take whatever's on the outside, we're going to multiply it by everything on the inside. That's what we're about to do in all the questions, regardless of if there's a coefficient in there, and even if there was another variable in there, we could even still do it. No matter what's going on the inside or the outside or whatever, we're taking what's on the outside and multiplying it by everything on the inside. That's what we're going to end up doing. Alright, so let's do the first one at the top. So I like I said, draw these arrows to help you remember who you're multiplying by everything. So 3 times x, and then positive 3 times positive 4 is plus for positive because it's a positive answer. 3 times 4. So you end up with 3x plus 12. And that's your final answer. You can't simplify any further, okay, because those are not like terms. 3x has an x. 12 does not have an x. Therefore, you cannot combine them with addition or subtraction. Now, I want to point out a common pitfall that I've seen students make. Do not do this. They would say, okay, 3x for the 3 times x, but then they would forget about multiplying by the 4, and they would say 3x plus 4. And that would be extremely wrong because you didn't distribute it to everything on the inside. So that's a common mistake that a lot of students make. So be mindful of that. Be careful of that. Another one I've seen students make is on the inside of the parentheses, they'll make what's in there a 4x. Because they'll say x plus 4, oh yeah, that's 4x. But that's not true. That's what x times 4 would be. And then they would multiply by 3. Then they end up with 12x. And they would say 12x was their answer. Many students get stuff like that. Or they would do 3x, get 3x, and then they would add the 4 like they had here, and then they would end up with 7x, and they would say that was the answer. But I want you to know, all of those are common pitfalls that students make. They are incorrect. So let's get those out of the way. I just want to see some things to avoid, some non-examples of using the distributive property. Now let's continue. If you think you've got the hang of it, press pause. Try these ones and then see how you did. But if you're not quite sure, you need to see a few more, check it out. Stay tuned. So negative 4 times w and negative 4 times positive 5. Negative 4 times w. Now negative 4 times positive 5, and negative times the positive, that's a negative. So you put a minus sign there. Negative 4 times 5. Negative 4 times w is negative 4w. Negative 4 times 5, that's negative 20, or in this case minus 20. And so that's going to be our final simplified answer for that example. I think you might be starting to get the hang of it, so maybe check out this next one. And you know what, just to make it interesting, I'm going to go ahead and change this next one slightly, just to make it a little bit tougher. Instead of saying k in there, we're going to make it a little more exciting. We're going to make it, I don't know, 4k. So we can do another example with the coefficient. Alright, so negative 2 times 7, negative 2 times negative 4k, that's a k, not a 41x. So that's a terribly ugly k. There we go, much better. Alright, negative 2 times 7. Negative 2 times negative 4k. A negative times a negative is a positive. And so I would go ahead and put a plus sign there. So negative 2 times negative 4. So we just said it's going to be positive. So really we just need 2 times 4k. Now, that's one way to write it. Or you may have preferred to have written it this way. Negative 2 times 7 minus 2 times negative 4k. I'm going to use a parentheses since it's negative. You could have written it that way. Either or, negative 2 times negative 4k is still going to give you positive 8k or plus 8k. So if you wrote it that way, that's fine. It's a preference how you like to keep track of your negatives. I just wanted you to know it is allowed. It means the same thing. Alright, so negative 2 times 7, well, that's negative 14. And then we have positive 2 times 4k, so that's going to give us 8k or plus 8k. So negative 14 plus 8k. That's the full simplified version of that expression. Now, if you wanted to, you're welcome to write that and change the order using what we talked about in the last video about the, in this case, would be the commutative property. You're welcome to say 8k minus 14 or 8k plus negative 14. They mean the same thing. So this is an or. You can use either one of these, but my preference would be, I don't really have one. In this case, because the letter was second, feel free to have it second in your answer, or put it first. It means the same thing. Now try this last one. Even though the number on the outside is on the right side, it's going to be exactly the same. So try this last one if you think you've got the hang of it. Press pause. I think you can do it. Alright, so let's see. 6 times each of those. 6 times 3x. Positive 6 times negative 5, well, that's a negative. 6 times 5. Now, so 6 times 3x is 18x. Negative 6 times 5, well, that's negative 30, or in this case, minus 30. So here we have our full simplified answer, 18x minus 30, using the distributive property. I feel I would be remiss if I didn't point out, by the way, distributive property, even if there's more than one thing on the inside of the parentheses, it still doesn't matter. You're still going to take what's on the outside times everything on the inside. You would just happen to do it 3 times. So 6 times 3x squared, that's 18x squared. 6 times positive 2x, that's positive 12x. 6 times negative 4, that's negative 24 or minus 24. So this right here would be the simplified version of that one. Notice that I didn't take time to show the steps on this, but I want to make the quick note of, even if there's more than 2 things on the inside, it doesn't matter. Distribute to everything on the inside. So before we go into these next examples where we talk about using the distributive property and then combining like terms, let's first take a vocabulary moment. Let's make sure we know what like terms are. Like terms are terms that contain the same variables with the corresponding variables having the same power. Now, speaking of which, a term is a number, a variable, or a product or quotient of numbers and variables. And in other words, if you look at this example, 6a squared plus a squared plus 2a, 6a squared is a term. A squared is a term. 2a is a term. Now, amongst those, you'll notice we only have one set of like terms, the 6a squared and the a squared, because they both have the same variable with the same coefficient. Now notice, a squared and 2a are not like terms because they do have the same variable, but they do not have the same exponent. So, like terms. Now, what we're going to do is, you know something is in simplest form, meaning we're going to simplify it using distributive property and then maybe combine like terms. You know it's in simplest form when it contains no like terms or parentheses. So that's what we're going to do in these next few examples. We're going to use the distributive property and then combine all like terms and simplify as far as we can. So take a look at these 2 examples. What I want you to do is I want you to apply the distributive property where you can and then combine all like terms that you possibly can. So take a moment to try these first on your own, maybe on a scratch paper if you're not quite very confident. Try these first on your own and see how you did, then press play. Alright, so we're going to start off by using the distributive property on what we can. So for example, by the way, there's nothing for us to do outside the parenthesis, there's nothing for us to do inside the parenthesis. Those aren't like terms. We can't do anything with them. So the only thing we can do is get rid of these parentheses by using the distributive property. So I'm just going to drop down the 3x plus, now 7 times 3x, and 7 times negative 4. A positive times a negative is a negative, so I'm going to put a minus there now. And then 7 times 4, like we said. So we're going to go ahead and multiply those out, just like order of operations. 3x plus 7 times 3x is 21x. Negative 7 times 4 is negative 28. So we have 3x plus 21x minus 28. Now what you're going to do is you've done the distributive property, you're going to combine like terms. You'll notice 3x and 21x, they have the same variable with the same exponent, which is technically 1, by the way. Not that it really matters in this example. So we're going to combine them the way it says. 3x plus 21x, well, that's 24x. So 24x and then minus 28. And that's going to be our final answer, simplified all the way. If you haven't done this last one already, maybe give it a shot now. As a heads up, that FG doesn't make it scary. It's just 4 times FG is just going to be 4FG. Don't overthink it. Alright, so 4 times FG, and then positive 4 times positive 3G is going to give us a positive. I'm going to put a plus sign there. So 4 times 3G, all of that, and then we're going to add 5G. Okay, I didn't mean to do the 5G in a different color. There we go, it's supposed to be black. Alright, anyways, 4 times FG, I already kind of gave it away. That's going to be 4FG. You technically can have more than one more than one variable on the coefficient. So 4FG. Now, 4 times 3G, well, that's 12G. And it's positive, so it's a plus sign. And I'm going to bring down the plus 5G. Now you're just going to look for like terms. Speaking of like terms, I see positive 12G and positive 5G. 4FG is not a like term because of the F. So it is not a like term. So let's combine what we can. Positive 12G plus 5G, that's 17G. And it's positive, so it's plus, and then we just drop down to 4FG. So this is our complete simplified final answer. 4FG plus 17G. And these are more examples. So what I wanted you to think about, let's do a brief recap and we're going to be all done. So let's go to the beginning. We talked about the distributive property. I remind you it's whatever's on the outside times everything on the inside. I gave it to you in symbol form in the bottom using letters, if that helps some people see it that way. Then we did some examples of showing how it works by using things that we know. When we knew everything on the inside, we knew what these were. So we knew for sure how to check our answer. We knew we could because it equaled the same thing up here. It equals 60, and it still equals 60 when we did each of them. So it was the same thing. So that's why we were kind of allowed to do that. And we did a few examples of that proving it. We then did some examples of with letters, with negatives, with positives. Now we have letters, we have coefficients for our letters. It didn't change. We were just using our same skills we learned about multiplying monomials times each other. And then I even showed you an example of even if there was more than one thing on the inside. In this case, there was 1, 2, 3 things on the inside. It doesn't matter. You just simply do the distributive property to all of them. And if you need to, combine any like terms, but in this case there were no like terms, so we were done. Then we talked about like terms, what it is what it means to be in a like term, to be a like term. We talked about simplest form, meaning no more like terms and no parentheses. And then we went ahead and did some examples of those. So at this point, you've now seen quite a few examples of the distributive property. You just need to take your time and make sure to avoid those common mistakes. A brief reminder of what those common mistakes were. The common mistakes were not multiplying by everything. So some people do the 7 times the 3x, but then they would never do the 7 times negative 4. They would just have a minus 7 right here. I'm sorry, not a minus 7. They would just put a minus 4 right here, and they would never do anything else. That would be a mistake. Make sure you do it by both things on the inside. Now, the only other common mistakes I tend to see in a lot of students is they're not careful with their positives and negatives when they're doing these, and then they make mistakes. So be careful, take your time, and we'll take it one step at a time. Then we'll take it to the next level. And this was really one of the last properties we need to worry about on top of our last video when we talked about all the different types of properties of real numbers. All right, guys, let's put this into practice. Let's stay organized, and we'll knock out these equations.